Earth is currently in the middle of a long ice age. And this ice age began roughly 2.6 million years ago. It's called the Quaternary Ice Age. You're probably wondering right away, the weather is getting hotter and hotter these days. So how can Earth still be in an ice age? Well, an ice age doesn't mean the entire planet is frozen solid. The real definition is whether Earth has long-term, large-scale, permanent continental ice sheets. When permanent massive ice sheets exist at Earth's poles or in high-altitude regions, that marks Earth as being in an ice age. Since huge ice sheets like those in Antarctica and Greenland still exist, Earth's high-latitude regions are still locked in a long-term frozen state. So strictly speaking, Earth is still in the middle of a major ice age. As long as that climate background of huge polar ice sheets is still around, the major ice age isn't over. And we're currently in the Quaternary Ice Age, which began about 2.6 million years ago and continues to this day. But here's the key point. Even within an ice age, there are cold glacial periods and warm interglacial periods. We're not living in a year-round freezing, glacier-covered glacial period. We're currently in a relatively warm phase within the Quaternary Ice Age, and this phase is called the Holocene Interglacial. It's a warm stretch within the bigger backdrop of an ice age. The climate warms up, glaciers melt, sea levels rise significantly, and large-scale marine transgressions happen. On the flip side, you have the glacial periods, the most famous of which is the Pleistocene Ice Age. During that time, the global climate was cold and dry, and about 30% of all land was covered by ice sheets. Sea levels dropped dramatically, and all kinds of giant mammals thrived. Saber-toothed cats and woolly mammoths, for example, lived in this era. Early humans also evolved during this period. It's the most recent cold period in Earth's history, and the one that shaped our modern environment the most. On top of that, these cold, glacial, and warm interglacial periods also follow a regular cycle. About every 100,000 years, glacial and interglacial periods swap back and forth. And there's a key mechanism behind all this, called the Milankovitch cycles. What it describes is actually pretty intuitive. On the surface, Earth's orbit around the sun looks rock steady. But if you stretch the timeline out to tens or hundreds of thousands of years, you'll find that Earth's orbit and orientation aren't actually fixed. There are three main variations. One changes in orbital eccentricity. In other words, Earth's orbit around the sun isn't always the same shape. Sometimes it's closer to a circle. Sometimes it's more of an ellipse. This affects the total amount of solar radiation Earth gets in a year. The second is changes in axial tilt. The angle Earth tilts, it actually shifts. Its rotational axis, relative to its orbital plane, tilts somewhere between about 22.1 and 24.5 degrees on a cycle of 41,000 years. This affects how intense the seasons are. The bigger the angle, the more dramatic the seasonal differences, with hotter summers and colder winters. The last one is precession. Simply put, the direction Earth's rotational axis points slowly wobbles on a cycle of about 26,000 years. This determines which seasons Earth's perihelion and aphelion fall in. Stack these three variations together, and they shift how solar radiation gets distributed across different seasons and latitudes. When these parameters shift, in a way that causes high-latitude regions to get significantly less solar radiation in summer, the snow piled up over the previous winter doesn't fully melt. It builds up and turns into glaciers, eventually triggering a glacial period. On the other hand, when summer solar radiation increases, glaciers melt and we enter an interglacial period. That's the core idea of the Milankovitch cycles. They give glacial and interglacial periods a beat measured in 100,000-year intervals. However, global warming may be pushing back the next cold glacial period. Massive amounts of greenhouse gases are causing Earth to hold on to extra heat. Through global warming, humans are forcibly extending this interglacial period. For the first time, we're not just living within Earth's climate. We're actually turning around and influencing this ice age cycle that's been running for millions of years. But what are the consequences?